Hello everyone. So today we are going to solve this functional analysis problem. So this is a very interesting problem, and you'll see many concepts involved here. And this is very standard problem. So you will see variation of this kind of problem in other different examination also. So let's read this problem. So two sets are given x and y, and two different norm. One is infinity and another is 2, and ux and uy are respective closed unit balls in x and y centered at origin, and two functionals have been considered on x and y, which is defined by these two equations, which are both are same but the domains are different. And two statements are given to us, and they are asked to check whether which statement is correct. So first of all, I will try to uh, find what is this value and what is this value, and then we'll see whether they can be attained or not. So let's consider first TF. So TF is mod of TF is nothing but integration from mod of 0 to 1 mod of f of t dt, which is less than equal to supremum norm of f, not supremum right now, but integration of 0 to 1 mod of ft dt, and then further this is less than equal to norm of f infinity. So supremum of TF when f is taking from the unit ball x, so this is less than equal to 1, right? Because norm of f infinity is always less than equal to 1 in when you take f from ux. But still this doesn't guarantee that whether this is equality or not. So to check whether this is equality, what you can do, you can try to consider a function in ux which is approaching towards whose area is approaching towards 1. So how to construct this? So what you can do, you can first take this function fx equal to 1, but if you look at this fx equal to 1, this area is 1, but this doesn't fall into this x, right? Because at f0 it should be 0 and f1 it should be 0. So this function is not in x. So you can slightly modify this function like this. I mean, this sequence of function you can consider like this, and you'll see that this area is slowly approaching towards 1. So the supremum is 1, right? So supremum is 1. So this quantity you turns out to be 1. And for the next statement, let's look at s of f equal to integration from 0 to 1 ft dt. So if you take the mod of sf, this is nothing but less than equal to not less than equal to, for the time being, equal to 0 to 1 ft dt, right? So here what you can do, you can apply Cauchy-Schwarz inequality. So because this is nothing but mod of integration from 0 to 1 ft multiplied by 1 dt, right? And this is nothing but norm of f2 norm, and then this is nothing but norm of 1, which is 1. So this is norm of f2 norm. So sf mod is less than equal to norm of f2 norm. So here what you can do, if you look at the supremum of all those f, so supremum over f coming from uy s of f, right? So here also this is less than equal to 1, because for any f in uy, its 2 norm is 1, at most 1. So here also you got this thing. And whether this is attainable, so what you can do, you can just consider the function f equal to 1. So you'll see that this is attained at a point. So this supremum is exactly equal to 1. So supremum is exactly equal to 1, and it is achieved by the function fx equal to 1. So the statement s2 is correct, but still we need to figure it out, what is s1. So again, if you try to visualize this quantity, what is this? TF is integration from 0 to 1 ft dt. So this is actually an average area in the interval 0 1, but if you look at f is coming from ux, right? So you have to restrict in this domain. So you try to visualize this thing. This is -1 and 1. So, and this is 1 here. So you wanted to draw a graph in such a way so that your area is 1, right? But if you draw any graph in this region, particularly in this region, which should start from this point, and its maximum area is at most 1, and which is not achievable. So you can try to draw any such graph, maybe like this, and then you'll see that this area is not 1, average area is not 1. So the max for the max possibility, you have to be above this x-axis, and the maximum will be achieved if you try to consider this kind of functions, right? But if you, and you try to push this line to this part, and then you see that maximum is only achieved at this graph fx equal to 1, but that is certainly not in ux. So that is why this is not achievable. So the statement s2 is true in this case and s1 is false, so because this is not attained at a point of ux. Thank you.